So, hi everyone, my name is Abhay, and my my project is predicting the unseen TANGO2 detection. So, TANGO2 deficiency disorder is a rare genetic disease that mostly affects children. About 60% of patients don't survive past the age of 9, and it can cause serious problems like seizures, heart issues, developmental delays, and intellectual disabilities. Now, detecting early is really hard because there aren't specific symptoms or blood tests to test for. So this makes diagnosis slower and reduces the chance of timely treatment. So now why this problem matters is because it has a high mortality rate and it can cause severe life-threatening symptoms. And like I mentioned, early detection is difficult and awareness for showing how dangerous the disease is pretty limited. And given the fact that it has like big impacts on families and healthcare systems, makes this a very important issue to uh, to research. So the reason why it's so hard to detect are because symptoms appear at different ages and can vary a lot between patients. And there's like not really clear biomarkers. So like no blood test can actually uh, test for it unless like the doctor specifically knows that the patient has Tango 2. And then also because these symptoms are like similar to maybe other more common diseases, um, it can lead to like misdiagnosis. And by the time like the patient is aware that they actually have the disease, it could become pretty severe. So for my research, my engineering goal was like to develop like an AI-powered early detection system for Tango2 deficiency. By integrating genetic, clinical, and environmental data, I want to provide a tool that can help doctors diagnose earlier and improve patient outcomes to potentially save lives. So my hypothesis is, can an AI model trained on genetic, clinical, and environmental data based on Tango2 deficiency more accurately predict than the current like diagnosis models that are very basic, which the hospitals have. So I kind of chose this hypothesis because early detection is pretty important with this disease, and I feel like with like the new frontier of like AI and trying to like use computer models to help detect different diseases, it can help like improve the outcomes for patients. So for my data collection, because Tango2 deficiency is so rare, I couldn't find like exact data from common sources like Kaggle. So I kind of gathered data from like the CDC and the Tango2 Research Foundation. I also spoke with like a doctor who was one of like the first persons to research Tango2 in Texas. And then she kind of like walked me through like how the patient's symptoms actually work and like some of the data that is needed for Tango 2. And then I also made sure to follow like all the HIPAA guidelines to make sure my data is like accurate. And so my approach to diagnosis the patients was first, obviously I had to clean the data and convert it into like categories and numbers that could be used to like actually train my model. And then next I selected like important features. So like for example, genetic information, symptoms, and then, like environmental factors. And then I trained a neural network and a model that one of the doctors recommended, which is called a random forest model. And then I tested the models on like separate data sets and evaluated the performance using different metrics. So, like I mentioned, the models that I used were neural networks, which learn patterns in data to predict the Tango 2 cases, and then the random forest, which like kind of like combines multiple decisions to improve the accuracy and reduce errors. So for my model development, I use a neural network. So there's like it has two like layers, which I made sure to include because just like the neural model itself doesn't really like isn't able to identify the different like it's only like used for straightforward classifications. But if I like add different layers in the ReLU, which is like a rectified linear model, it helps like detect like kind of like the complex patterns that may be associated with like disease detection. And so I did some research on this, and many of like the research like models that people use in the hospitals to detect different types of diseases use this types of models. So I decided to like try to include this in my own research. And then I also use like the random forest model. So it uses different decision trees. So like it takes like an output that it wants to like detect, and then it makes a tree like it branches out from there, and then it tries different cases and sees if that works. So this is kind of like a code that I used to make it, and this is my results. So you can see. that after training I kind of like created these results. So the first one is like the ROC. So basically it like shows how well like the model actually distinguishes between patients with and without Tango 2. And then the logistical regression model, which I kind of use, has an area under the curve of the AUC of around 0.87, and the rainforest has around a 0.90. So this is the one on the right. So what that means is like the closer it is to one, the more accurate it is in actually like predicting different cases when it's comparing the model to itself. And then the next one on this side, or the left side, is called the Kaplan-Meier curve. And so this kind of like it's like a survival probability curve. And so it starts off with like 100% like symptoms, like they're not being able to be detected. And then it goes down until it reaches like around, like I think if you look right here, like around 50% is around like age 4 to age 5. So that's when like most of the symptoms actually start showing up, which doctors are able to then detect it as Tango 2 in like the real world. So this kind of indicates like the survival probability of the patient uh, based on like the model and how it detects it. And so different ways I kind of evaluated my model was because first the ROC curve kind of like shows us how well the model can actually distinguish between patients with and without the Tango 2 deficiency. And the closer the curve is to like point 0.1, it's more accurate. And since both the regression model and the random forest kind of had um, like a prob like a score of around 0.87 and zero point 0.9, that basically means that it's fairly accurate or pretty accurate when predicting these different datas. And the second one was the Kaplan-Meier, and this kind of shows up probability and survival over time, like I mentioned. And the reason this matters is because both of these help them with model accuracy, and it shows how the patient outcomes tend to like progress as their age increases and as the kind of like as the disease progresses. So this is kind of just extended. So this is just evaluating my model's like accuracy. And so from the matrices, we can kind of like see that the neural network was more better at identifying the true positive cases, which is critical because a missing Tenga 2 case could have serious consequences. And the neural network was slightly higher in position and recall for the positive cases, meaning it's more reliable for detecting patients with the disorder. So basically what this slide is kind of explaining is that the random forest classifier was great at predicting different cases where the where like the progression of the cases of like whether or not the patient actually has Tango 2 or not. So because it uses the different like trees to like model this, and then the neural network was kind of better in like predicting like the outcome of the Tango 2 patient and seeing whether or not the patient is developing the symptoms that align with like the Tango 2 deficiency. And then, so my conclusion is that this project kind of like aim to develop like and aim to improve patient care and outcomes. And then I also found that early detection enables timely treatments and reduces stress on families and healthcare systems. Some of the limitations are that it was not like a huge data set because of like obviously like how pretty rare this disease is. And so and there is need for more research in this field. But some future directions that I could is obviously refining the models and exploring like different data sources to improve accuracy and representation. And then one more thing that I didn't include on the slide was also like presenting my information to the doctor that I like kind of met with and discuss with that I got the data from, and also like presenting it to like maybe like a Tango 2 foundation, because those are I feel like those are foundations and people that would greatly benefit from my research. And this research that I did could definitely be used in maybe like hospitals or maybe even like tested in the real world to see if it can actually help detect Tango 2 and help with patient outcomes. Thank you for listening. And yeah, these are my references. Thank you.